Hello. I guess we're back at it again with another problem. Yup. Don't know what else to say. So let's just get into it. We're doing this problem called search in rotated sorted array. There's an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k. 1 is less than or equal to k, which is less than nums.length, such that the resulting array is nums sub k plus 1, blah 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 until nums n minus 1, nums 0, nums 1, blah blah blah, nums k minus 1, 0 indexed. For example, 0, 1, 2, 3, 4, 5, 6, 7 might be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algorithm with O of log n runtime complexity. So this is going to be another binary search question, as you can probably tell from the O of log n runtime complexity. And yeah, so I guess we'll just get into implementing the solution. So we're gonna have our, classic left, right, and the length of nums minus 1. And the classic while left is less than or equal to right, we're going to be doing things, right? Such as mid left plus right minus left floor division divided by 2. And then if we obviously find the number, we want to return the index at which we found it. That's the basis of our, binary search. If we never return within the while loop, that means we never found it, so we want to return -1. Pretty basic for all of the binary search problems that we've done so far. And so now this part is obviously the condition on which, do we go to the left, do we move our left or right variable? That is, the biggest problem that we have, right? And so what we're going to do is if nums left is less than or equal to middle, then not middle like this, nums mid, sorry, the value in middle. So basically this means left side is sorted, right? If the left side is sorted, now we got to determine whether or not our target number resides within the sorted area, right? So if nums left is less than or equal to target and target is less than nums mid, then we want to go toward the left, right? So we'll do right equals mid minus 1. Else, then it's on. Otherwise, if it's not in the sorted side of our array, then we know it's on the right side, right? So if it's on the right side, then we do left is equal to mid plus 1. And then, so essentially to explain this, let's look at this value, right? So instead of target is equal to 0, we'll look for, let's say we're looking for 6, right? So with this array, if we go the middle, we get 7, right? Because left is 0, right is index 6, 0, 6, and then the middle of that would be 3, right? So 0, 1, 2, 3, we get the number 7. 7 is not the target, we're looking for 6, right? Now we want to find, so we look at the left side right here, right? So left is 0, so num sub left or 0 would be 4. And so 4 is less than or equal to the number that we're currently looking at, mid 7, for sure, right? So now we know this left side is sorted, right? Now, now we want to look at where where our target resides. Does it reside in the sorted side, or does it, well, I guess it's only up to here because we don't care about mid anymore because we already know it's not the value. So does it reside in the sorted side, or does it reside in the other side, right? So 6, well, 4 is less than or equal to 6. That's true. 6 is also less than 7. That is true. So we'll just make right is equal to mid minus 1, which is 3 minus 1, 2. And then otherwise, so in like the 0 part, right? So if we're looking for 0, 0 is not in here, so we know we can just move it. So left will equal to mid plus 1, right? And the else, this would mean the right side is sorted. Right, let me move enter that. We don't want that too close. If the right side is sorted, then it's just, you could use the same example if we just put -1 here, right? And so the right side would be sorted, and you would just do the same checks again. So if nums mid is less than target, and target is less than or equal to nums right. Let me see, is that right? Yeah, so if the right side is sorted, right, then you have target, which is probably somewhere in the right side. So if we pretend this is a -1, and let's just say we're looking for 0, right? -1 would be less than 0, that is correct. And 0 is less than nums right, less than or equal to nums right, which is 2, that is also correct. So therefore we want to move left to the right. So left is equal to mid plus 1, and then else, that means it's not in the sorted side, so right is equal to mid minus 1, right? And we return -1 because we don't find it. That should make sense, I hope. Yeah, I mean, I don't know what else to say about that. Let's just submit those problem. Boom. The solution works. So yeah, thanks for watching.